On to the exercises. I'm going to read in the flights data set here. What are the three airlines with the least number of flights? Okay, you don't need a custom aggregation functions here. You can just use the value counts and say tail like that. Pretty cool. So we get the last three. Those are it. Number 2, for each airline, find the 75th percentile of flight distance. Use a custom aggregation function. So flights dot group by airline again. And we will aggregate here. We're going to use flight distance. Yeah, so ag, we'll say quant 75. So actually I'll just do percentile. Let's just call this new column P75 for 75th percentile. And I'm going to use the distance, and I need to get the 75th percentile. So there is a quantile function that is built in, but by default it returns the 50th percentile. So you have to use a custom aggregation function here. And we'll just call it P75. It's going to take a series, and we're going to return s.quantile, and you have to give it the 75th percentile like that. And we need to change it. Obviously, we're going to use our P75. All right, there we go. All right, number 3, for each airline, find out what percentage of its flights leave on a Tuesday. All right, let's look at our data. So we're going to definitely group by airline. So for each airline, and then we have to do definitely have to have a custom aggregation function. So percent Tuesday, we'll call it S. And we're going to pass in the date column. So s.dt.dayname. So you have to know this one. If you don't, then just select the column you want outside of here in practice. So if you don't know that, you just say date equals flights of date. And let me just, we'll call it date. And if you forgot, you do dt dot, and you're like, all right, which one do I need? Sorry, which one do I need? And it's not showing the right ones. Okay, let me go to a new cell. Okay, sometimes it doesn't show the right one. There's a little bit of a mix up there. So just go to a fresh cell, and that can clear that up. And yes, we can do day name. Just need to figure out how to get whether or not it's Tuesday. Okay, so we'll use that dt.dayname equals Tuesday, and we will take the mean of this Boolean series like this. Let's just say percent Tuesday. It doesn't have to be the same name, right, as the function. I'm just naming it that just to show you. I'll say percent Tuesday equals, I'm going to aggregate date, and I'm going to pass in this percent Tuesday function that I just created. Number 4, optimize exercise 3 without using a custom aggregation. What is the performance difference? All right, let's go ahead and do that. So here's our original, so let's bring that down. We don't have, this is independent of the group, whether or not it is Tuesday or not. So we'll just say date. We just literally just copy this over here. We could make a new column called is Tuesday. Let's say is Tuesday like this. And then we can just group by, just take this. And instead of grouping is date, we'll just say is Tuesday. That's the column we just did. And we just take the mean here. And that will give me the same exact results as that one. All right, so how do we can time these. We can say percent time. All right, that gives me 26 milliseconds. And here I'll just hide the results just so I can see the time. Same thing here. I'll just say percent time. Okay, so it is it's okay. It just says it's a small improvement. We can also convert this to categorical, although it's not going to make a big difference here because it's a small data frame and there's not too many airlines, so there's not too many groups. All right, number 5, the range of salaries per department was calculated using the min-max custom function from the beginning of this chapter. Use the same function to calculate the range of distance for each airline. To then calculate this range again without a custom function. Okay, so flights.group by airline, and we'll use this syntax. We'll say the distance, and we're going to aggregate using the min max that we created before, like that. Now it says, how do you do this without a custom function? So I didn't really explain this, but we could take the min and the max like this. So we're going to produce a intermediate data frame. And just so we can show our work here. And then we can just take the max column minus the min column like this. So we can subtract these two columns. So this does it. And you should see that this does in fact give the same results, 1297, 1297. All right, number 6. Which origin airport has the highest percentage of its flight canceled? All right, so here's the origin airport. The highest percentage of its flight canceled. So we need to find the percent, which origin airport has the highest percentage of its flights canceled. All right, so we don't need a custom aggregation function here. Flights.group by, and we'll group by the origin airport. We can get the canceled column and just take the mean. That's the percentage that are canceled. So canceled is either 0 or 1. And we could just get the top one, so n largest of 1. So the Boston airport has the highest percentage of its flights canceled. All right, we're going to use the college data set for the next few. All right, so just these columns. How many states have more schools with a higher SAT verbal mid than SAT math score? Make sure to not count schools that have missing values for either one. All right, so we have to make sure we don't count schools with missing values. We'll do this without a custom aggregation. So we're going to just drop any schools that have a missing value for either SAT verbal or math. So we just can't make that comparison. So now all of these have a value, these two columns. We'll just reassign this. So C2 is our new data frame. And just to show you, we can show that there's no missing values in these two columns. That's what really counts. Now what we want to do is compare. Okay, how many of these have greater verbal than math? So we're going to find the schools that have the states, that have more schools with higher verbal than math. Okay, so this will determine whether or not a school has a higher verbal or math. And we're going to go ahead and assign this to a new, we'll say higher verbal, like this. So this will add this over here. It's saying we're making this is a warning. So what we can do here is really call .copy. So this will copy this and make sure that there's no warning. So this will be a completely new data frame, not associated with the original. All right, so we have higher verbal over here. Now we can do our grouping, and we don't need a custom aggregation function. So it's a group by state abbreviation. Which states have higher SAT verbal? So we're going to use this higher verbal, and we're going to take the mean of this one. And, oh, I misspelled a higher verbal. Let's go ahead and rerun this. All right. And what we're looking for are the states that have more than 50% over here. And those are the ones that have a higher verbal. So we can just assign this to something like S, and then we can filter out the ones that are at least 50% or higher, like this. So pretty cool. That's how you can do that one. No custom function needed. Number 8, create a pivot table that shows the percentage of schools with less than 1,000 students in each state by religious affiliation. Also return the count of schools. All right, the first thing we can do is just show the raw counts of these. So by state and religious affiliation. So the state will go along the index. The columns will be religious affiliation. And the values here, well, what are we going to aggregate? Well, at first it won't matter, but it will matter the second thing. So we'll aggregate UGDS, that's the undergraduate student population. And then the agfunc for now, we'll just say is count. So I'm just going to count the number of schools that have a population, right? This is the number of non-missing values. So this could just be all of them. It just depends if there's any missing values here, but it's just saying. So in Alaska, there are 7 that are not religiously affiliated versus 3 that are. So you can see here, those that are versus those that are not. Okay. So what we need to do now is we want to find we want to show a pivot table that shows the percentage of schools with less than 1,000 students by religious affiliation. Right, so we need to figure that out, and we need a custom function for this. We're going to say, we'll just call it less than 1K as the function. So we're going to be passing in this UGDS, and we're going to see, so for this state and religious affiliation combination, what percentage of these 7, or of these, let's use a larger number like Arizona has, or Arkansas, I guess, has 68 schools. What percentage of these is less than 1,000? Right, so we're going to say S is less than 1,000 dot means. That's all we do. And for aggregation, we're going to do both aggregations. We're going to say less than 1K and count. And now this should do it over here. So this is saying that, let's go back over here to Arkansas, almost 59% of the schools of these 68 have less than 1,000. 61% of those that are religiously affiliated have less than 1,000. So pretty cool. So we're breaking up the schools by less than 1. That is our aggregation, right? We're determining whether or not, what percentage are less than 1,000 based on religious affiliation in each state. All right, so that does it for all of the exercises.